I am Miguel Ángel Mezquita Santoyo, and this is my argumentative exam. So the first problem includes solving this circuit that includes resistors, a battery, and a current source. First of all, we have to identify the nodes, as we can see here. I chose this as the ground node because it's in the negative side of the battery, and this is the battery voltage node. We put a total of 7 nodes, and then the next step should be do the nodal equations. These nodal equations are they come from the Kirchhoff's law that states that all the current that goes in and out of a node should be equal to 0, all the sum of it. So here it goes, the voltages and the resistors all equal to 0, forming the nodal equations. Then the next step is to reorder the variables, as we can see here. So V1, V2, and V3, V4, V5, they are just zeros in this case of this equation. And we basically reorder all the equations and factorize them. The next step is doing the matrix form. Using the previous equations we did, we put, in matrix form. So this is the matrix, and we first put the first matrix, then the second one that comes with the values and the results that come also from the equations that we previously made. Now, putting this into MATLAB, as we can see in the right part, here we put all the values and the code, and MATLAB throws up these values. And we node them in the part right here, in the node values report. We also, to make sure we are right, we run a simulator where we can see here that actually the nodes are correct. Now, in this part of the analysis, we want to find the electric current going across, first of all, the voltage drops going across each resistor, as we can see here. So we do the more voltage minus the less voltage, and they are all the way over here of each resistor from 1 to the 12th resistor. Then with that value, we divided it into the value of the resistor in ohms. So in this case, in the exercise, it was the resistor 1 ohm, resistor 2 ohms. So we did that, and we have all these values for the amperes. Now, for the next exercise, we have 2 circuits. I'll start with circuit A, and it's basically the same procedure. We have to first find the nodes. So I chose this as ground node, the battery voltage node, node 1, 2, and 3. So we made up the nodal equations, also as I said, using the Kirchhoff's law and Ohm's law. And we factorize the nodes, and we put them in matrix notation. After putting it in MATLAB with this code, the node values that MATLAB says it are these ones. Then we make the electric current analysis. So the voltage drop going through each resistor divided by the resistor in ohms. In this case, it was 1, 1.5, a half, a third, a fourth, and so on. So we have these amperes. Also, to make sure, we have the simulation We have here the diagram and also the values of each node. Circuit B is also basically the same. I took this as the ground node and this one as the battery voltage node and the other 3 nodes. It's also necessary to say that we had, so because of the time I will skip this circuit B, but it's basically the same procedure that we've already covered. The nodal equations, factorization, matrix notation, then MATLAB, and the electric current, and to make sure the circuit simulation and the node values. So we go to problem 3. The problem 3, we have to find some values according to a particle and in a battery of 100 volts, as we can see here. So the values that the problem gives us are these ones. So first of all, we have to do a little bit of maths, and using this formula, we can also use the formula that force equals mass times acceleration, and we got this formula that acceleration equals this formula, where E is the electric field, Q is the charge, M is the mass, and D is the distance. Putting the values into the formula, we can have now this acceleration. That, as you can see, it's negative, but here we have the explanation. The acceleration in the particle is negative because it's going in the opposite direction of the magnetic field. Now, the other thing the problem asks us to do is to find the time. So we use the formulas of physics to find time. So we use this part. Then to find the kinetic energy, this is also a simple formula. We just substitute the values and we have this result. And finally find the velocity, also a simple formula. Velocity equals acceleration times time. We substitute the values and we have this velocity. Also notice it's in negative because of the acceleration is also a negative. For problem 4, we have to find the resultant vector that is in the middle of all these charges. So first of all, we have the measures of the square. That's basically A times A is a square. And first of all, we put the coordinates of each charge, and we use QC, meaning Q center, as the graph in 0, 0, 0. So according to that, this should be half A. So here we have all the coordinates, A halves, comma 8 halves, A halves, and so on with all the coordinates for the 4 charges. Now to calculate the resultant vector, we have to sum each one, as it's stated right here. So we make the calculus for each vector using the same formula. So it's basically the same for each vector, and we get a point for each point. Then we add them up as a resultant vector. That is just right here. And as we can see, if we sum all of the points in x and in y, we have 0, resulting in a net vector of 0. So basically, it just stays there. But we can also have it in MATLAB. Here it is, the code. And what MATLAB throws is this value. That is really small value, so it's basically 0, but just a little bit of error. In the problem 5, we're asked to solve a little bit of problems for a capacitor. First of all, what the problem gives us is this data. First of all, the capacitor should be 1 microfarad. Then we have to find the area of the plates, this constant of vacuum permittivity, and the separation of 1 millimeter. First of all, part 1, geometry. We just put the data in the formula and of this formula, and we get 113 meters squared. Then the part 2 is the charging process. The given formula this, and the constant of time tau, that is R times C, as with a resistor of 100 ohms, and the capacitance that we have already seen. Now this is the value of tau. Then we calculate the formula in here to for it to give us the time that is right here, and the problem asks us to have the time for the capacitor to charge to 25, 50, and 75%. So we just use the formula of this formula, and this is the data in the time in seconds the capacitor takes to charge. Now for the discharging process, we have this formula. We also, as in the other problem, we solve for time. So, and we have to find then the time that it takes from 100 to 30%. So here it is, using the formula. Then the exam asks us to do all the graphics in MATLAB. And here they are: the charge versus time, the voltage across the capacitor in the charge phase, the voltage across the capacitor in the discharge phase, and the voltage in the resistor across time. As we can see, these are graphs that are in exponential graphs. In the part 5, they ask us why to use tau as a constant of time in RC circuits. And it's basically because, as we can see in the graphs, all the behavior of the capacitor is going in time as it goes to 5, but 5 x 10 to the minus 4, that is the value of tau that we found. So basically we use tau because the behavior of the capacitor, so it adapts to that value. In this case, it was that value of tau, but with other RC circuits, we could have different values and still get 5 tau for the charge and for the discharging time of the capacitor. And also there is the code in MATLAB for the graphs.